The diagram here is the sun. Producing tremendous amount of energy every second. Its power output is 4 times 10 to the 26 watts. Okay, so here in March, neither one of the two poles is closer to the sun. But in June, the North Pole is tipped more strongly towards the sun than the South Pole because the direction of rotational axis stays more or less fixed in space. And then the northern hemisphere receives more direct solar heating, and therefore the temperatures go up. Then in around September 21st or so, we have a situation similar to that in March, where neither one of the two poles is tipped more strongly towards the sun. And then around December 21st, we have that the North Pole is tipped away more than the South Pole, and therefore the Northern Hemisphere receives less solar heating and the temperatures go down. The distance between the Earth and the Sun doesn't vary much. So it's at most 2%, 1.7% is the change in distance. In fact, it turns out that in January, when it's really cold in the Northern Hemisphere, the Earth is closest, its center is closest to the Sun. And then in June, in fact, on July the 4th, the Independence Day in the US, it is actually at the greatest distance from the sun, but the changes are tiny, and therefore the change in Earth's distance from the sun is not the cause for this seasons. It's this tilt of the Earth's rotational axis. Now, as the Earth revolves around the sun, to us on Earth, it appears that the sun is moving along a celestial sphere, along a path on the celestial sphere among various constellations. I've shown a diagram like this earlier. Right? So as the Earth revolves around the sun, it appears to us that the sun is moving among fixed stars and constellations in this direction, right? From west to east. Now, this projection of the sun's path among the stars and constellations on celestial sphere is called the ecliptic. So here I will complete the celestial sphere. What is shown in this diagram is only an intersection essentially given by the orbital plane of the Earth around the sun. Okay, so the projection of the Earth's orbit on the celestial sphere, which also gives the apparent path of the sun among the constellations, is called ecliptic. And the constellations that happen to be along the ecliptic, there are 12 of them designated here, but I mentioned before that one is missing. There is Ophiuchus here between Scorpius and Sagittarius that is typically left out, but it's actually there. These constellations are named zodiac, right? Which in Greek means the circle of animals.